Hey there, Math 120 fans. I just wanted to do a rundown of Chapter 1, give you an example of what my lecture looks like, and then I'll follow up with a short video about the homework. The first few chapters are really important in terms of getting to know what the course is about. I won't post a video for each one, but I'm going to try to do a quick version of what my lecture looks like. So anyways, the class starts with me just doing some warm-up questions. I ask questions like this. So you should try on your own. These are things that hopefully you don't have to look over at a formula to figure out. But hey, we're going 60 miles in 2 hours. What can we say? 60 miles in 2 hours. And I always say that means you're probably in Seattle. The traffic is so bad. So we're going an average speed of this. That's this formula. This is an example of a rate. And what I talk about in this lecture is that unit conversions, rates, they're all kind of intertwined. We talk a lot in class about really calculus is all about rates. That's what the whole point is. So this is useful in many ways in this course, but especially if we're going to do some problem solving. So then we talk briefly in class about how speed is distance over time. And I try to emphasize the fact that yes, we have these formulas, but they're not like things to memorize. By the end of this lecture, you'll be able to do all of this without memorizing these formulas. But I do mention that if you have a formula like speed is distance over time, you have to get comfortable if you're going to go on in math rearranging it, realizing that if you have that, you also have the formula for distance, you also have the formula for time. But for me, it makes more sense to attack the units. So a rate like this can be thought of as a conversion. It's basically saying that for this person who's struggling on I-5, 30 miles is equivalent to 1 hour. That means if we want to convert for this person in this car between time and distance, we have a way to do it. It's a way to think about it. Conversions in this course, we're going to have some imperial units. Sorry for those of you that are from another country. We're going to have some metric. Sorry for those of you from the US. If you continue on, there's going to be more and more metric. Those are just the things you need to get started. The rest of these questions were just getting people to play around with this. So in class we said, okay, the one way you could do this is convert everything, make it all hours or make it all minutes. And that was one discussion we had, and plug into a formula. But I'm going to talk about how I just would think about this as a conversion. We are given 160 minutes. And this, I think of a lot of math this way in terms of what I'm given and what I want. I want how far. Now, occasionally I'll see students underlying everything in a problem. It's not like you're a machine. We're going to practice and get better at just reading. How far is a distance? So we would like miles. Now, the question doesn't say if it wants it in miles or feet or anything else, so you can give it however you want it. But this sort of tells me everything. Notice I can talk and still just do it. I want to go from the time they gave me to miles. It's a conversion. Now, the thing I do know is I'm going 30 miles per hour, so I have a way to go from hours to miles, but I need to get rid of this minute. So to me, it just lays out nicely this way where I don't have to think in terms of formulas. It's okay to use the formulas too, but I'm trying to be sort of practical in what I think will help you. So I have a way to get from minutes to hours. I think of it as multiplying by 1 in a clever way. And I have a way to get from hours to miles. Now this is the rate part. 1 hour is 30 miles. The other comment I always make is that it's very worth your time, and I think even more so now than ever, to pause for a moment before you reach for your calculator. The more you do that, the faster you're going to get at it. And I have seen how this really hinders people in our calculus courses because they're having to reach for their calculator for every bit of minutia, and it makes problems take forever. So when I look at this, I think I see so many students will do 160 times 30, which is like following some weird strategy. Put these two things together. Organize them how you like. When I look at this, I see 30 over 60 is a half. And then it's 160 times a half, and I'm done. We're done in like a moment. The more you do that, the more you allow yourself to do on the homework, the better you'll do at that, and it'll make you dramatically faster. Sometimes you look at it and you're like, I don't see an easy way to simplify. Then you reach for your calculator. But it's worth 3 seconds a breath. Okay, how long? That's time. So we want time. Now the question doesn't specify what we want. Let's pretend that I said I wanted minutes. And I did this one in class, but I wanted to give us one. And what did they give me? They gave me distance. Okay, so we need to somehow get from 50 miles to the number of minutes. What can I do? Well, I know how to get from miles to hours. So let's set this up. 30 miles, 1 hour. And then I want to go from hours to minutes. You could also, it didn't specify what unit. I had a few students come up to me after class and they're like, why did you do it in hours? So I thought, here, we'll do it here. And look, you can do this one in your head too. It is amazing if you allow yourself to practice simplifying fractions, how much faster you get at it. That's 100 minutes. Okay, so that's how I think about unit conversion, but at the same time I'm exploring rates. Rates are about predicting the future and working. Okay, so that's what I did at the start of class. Because we were doing syllabus, so we didn't get to do more examples, so I'm going to follow here with doing some more of the rest of the lecture. Okay, so what I had planned to do next, and I'll do some of this on Friday, was just to do another example. Olaf is actually one of my cats. He goes faster than this. But here it's 40 feet in a minute. How long? Okay, what do I want? What am I given? And I don't think of this method, whatever method I'm giving you for problem solving is not rigid. I'm not saying you have to do this. I'm giving you cues that can help you when you're stuck. How long? I want the time. Doesn't say what units, so let's say we want minutes. What am I given? 2 miles. I'm also given a rate, which I can think of as equivalence. But it's feet in minutes. So what can I do? All right, I'm going to turn miles into feet. So I'm giving you a way to think through it. My goal in this course is not for you to be a machine. It's to have tools to sort of think through how you would do a question. That's much more valuable, in my opinion. Okay, and I know that for Olaf, 40 feet is equivalent to 1 minute. There we go. Even again, just to sort of push the point here, if I was simplifying this, I feel like I'd like to put the 2 over the 40 instead. So in my head, what I'm thinking about, and I usually don't say so much about this, is that I would just write 1 over 20, 2 times 1 over 40. And then you might say, well, I don't know how to divide by 20. It's time to reach for my calculator. But honestly, I hate reaching for my calculator. So I actually would just divide by 2 and then divide by 10. Or some students like to think of this, divide by 10 and then divide by 2. So it's a half of 528. So 250 plus 14, 264. I am not someone that grew up naturally good at arithmetic. It's something I've practiced, and it really is much faster. It will help you a lot in your future courses. What is Olaf's pace? So I was going to talk in class about pace, this idea of that's just another way to think about it. Often we think about that as a runner. How many minutes does it take me to do a mile? So here what I want is minutes per mile. And what was I given? I was given that, okay, I know that it takes 1 minute to go 40 feet. So it's really about turning feet into miles. I can see. So this was mostly an opportunity to see how we think about this as an equivalence, as 2 things that are equal. How we basically think about this as 1 for Olaf. Now, Olaf is my cat. I used to use an example that was my guinea pigs, and they were much slower. This is going to be a very slow pace, but 5,280 feet, 1 mile. Again, worth just a moment to think about what you could simplify. Oh, so it's actually going to be half of this number I had up here. Again, it's just something I practice. So half, this is going to be 100. Half of 64 is 32. 132. Olaf is really slow. He can be faster than that. Okay, that's the nature of quite a few of the homework questions. So when you go to the homework, you're just going to be computing those things. But what I really like is you to have this technique, this organized way of thinking. So then I had one that's just a rate, a more general rate that's not speed. So this time it's the rate of an area of a puddle that's growing. Find the area in 90 minutes. So you start to sort of see the habit. You're given 90 minutes. You want to know, you want the area. So that would be square centimeters. And you have a conversion between them. You know that in 1 hour it will grow 5 square centimeters. Now, one thing about a pipe leaking with a puddle, and if anybody's interested, this is the sort of stuff you got this water leaking and it's forming a puddle in the ground. There's a whole bunch of interesting things about that. I did some research on it a while ago. You might notice when there's like a dot of water on the ground that it actually forms a little bead. And that's the surface tension. So the edge of it, there's so many interesting things to say here, but that's not what this problem's about. I'm getting distracted. Water is really interesting to study. Okay, so what would I like to do? I'd like to get it to hours. So here's the minute, here's hours. Pretty much anything in the natural world in your life, if you dig a little bit, there's some interesting math in it. We spend these times doing kind of dry problems, and so we think, oh, it's just this boring thing that a weirdo guys named Dr. Loveless can do, but so here we go. So this is going to be 90 over 60, 1.5 times 5, 7.5. Okay, good. So I was just going to talk about how, hey, any rate we can kind of think this way. So a lot of questions are going to end like this. At the end of some question, it'll say how long or how fast or how big, and you'll have to do a little bit of either thinking of it as a conversion or not. There was a few questions in the homework that mix in your previous knowledge. It says, oh, this is a circle. I want the radius of a circle, and I know the area. What am I going to do? So I want the radius. I'm given the area. So you can see how things I can do before I allow myself to panic. So sometimes people go, I don't know what to do. I got to look something up. Don't look something up. Just first articulate. I want the radius. I was given that it was 90 minutes. I know that 90 minutes goes with this area. And we're talking about a circle. So now you can start to sort of formulate. What is the area of a circle? Ah, that's the thing we need. That's why you put that on this page. So there's a little bit of solving to do here. So you're going to have to remember how to solve. We got to divide by pi. We got to do the square root. These are the sorts of little skills, if you're struggling with, you can ask me about on the discussion board. Keep lots of digits till the end. R is plus or minus the square root. So there's going to be bits of algebra mixed into the homework as we go. And I did a decimal for this, so I do have plus or minus 1.545096. Typically in the homework, it'll say like round to 3 digits or something. So 1.545. What am I looking for? Radius, centimeters. 1.545 centimeters. So for me, I don't know if you're getting this, but this is more exciting to me than just doing a bunch of problems where I plug into the formula of a circle or I just do a straight conversion. That's kind of the nature of this course. Okay, maybe I'll stop there and talk about the last example separately and take a peek at the homework. I hope you found that interesting.